off to the second game. We're gonna be playing just the basics of it in this video. There's a lot of nuance to this next one with composite functions, the second composite function game, or like your quiz 3B. Hey, kitty. I should have had the video on for that. I can't just tell right off the still, you know. I'm pushing forward. Sorry. Okay. So you got your quiz 3B, and this is just going to get you the basics to be able to run through these. We won't solve the whole thing. You'll have to watch the next one. There's nuance to this. There's a lot of weird. So let's just jump right into it. All right. Cat fails are dope. Here's our rules. We now, instead of having the inverse on the inside, we got the inverse on the outside. And sometimes it's kind of tough to tell which one's which. But this one is going to be an angle on the inside, so it's an angle in and an angle out. And the last one, it was a ratio in and a ratio out. So whatever's in there, you see those pies in problems, you can be like, all right, I'm playing this game. So here comes the game, and here's the rules. Your input will be the output, as long as that x value is in between negative pi over 2 and pi over 2. That's the range of sine inverse of x. That's also saying that the x value is in quadrant 1 or quadrant 4. That's what we mean by, remember that inverses are angles. The answer is going to be an angle, because inverses are angles. So we're either in quadrant 1 or quadrant 4. When we go to cosine, we're going to say, well, it's going to pop out its answer, but only if it's in quadrant 1 or quadrant 2, in between 0 and pi. Only angles between 0 and pi. Now, we're always going to get an answer for all of these. It's just we can guarantee that the input will be the output if these conditions hold. If not, we do a little bit more work. And lastly, for inverse tangent of x, it will equal x if those x values are, oh shoot, the x values are now angles. So we're talking about quadrant 1 or quadrant 4. Same thing as sine inverse, except we just don't include the endpoints for inverse tangent. It never achieves those. All right, let's see it in action. Got a problem here? Sine inverse of sine of pi over 3. So we look up and we're like, all right, well, are our x values, or is the angle? Screw the x part. I got to put something in there. I could have put a theta in there, but I didn't want it. I wanted to put x in there. It's an angle. So is pi over 3? Is pi over 3 in between negative pi over 2 and pi over 2? Because this is the only place, if you see a sine inverse, you can only get answers that are in between negative pi over 2 and positive pi over 2. But we know that pi over 3 lies in here. There's pi over 3. So the answer must be pi over 3. That's what this theorem up there, this is what we're writing up. That's what this in blue that just made disappear. That's what that guarantees, that we know the answer is pi over 3. Let me show you why and prove it to you just a little bit so we get sine inverse up, and we can just solve on the inside. What's sine of pi over 3? It's root 3 over 2. Well, sine inverse of root 3 over 2 is equal to pi over 3. Creates a one-to-one function. Let's go to our next one. This one's got a tangent inverse. Okay. Tangent inverse of tangent of negative pi over 6. Well, tangent, again, what is that, negative pi over 2 up to pi over 2, but we don't include the endpoints. We never actually get there. So as long as negative pi over 6 is within there, as long as it's here, but that's actually where it is, negative pi over 6, then our answer must be negative pi over 6. Now, I'm doing some of the simple ones that you can solve, and you could maybe just punch into a calculator and get your answer out. We'll do more tricky ones than just this. Tangent of negative pi over 6 is equal to negative 1 over root 3. Since inverse tangent is an odd function, we can let that negative travel to the front, and we can just look at that one table I've been talking about the whole time. Going, which one goes with 1 over root 3? What angle? And that's pi over 6. So we could say our answer is negative pi over 6. Same answer, just I went the long way. But if you know the theorem, you could just state it. That's not really a theorem. It just is. I misspoke when I said theorem. That's not true. Now let's go to this one. Sine inverse of sine of 2 pi over 3. Before we even start, 2 pi over 3 is not between negative pi over 2 and pi over 2. All right, from up here, let me just drop that one. Sine inverse is between negative pi over 2 and positive pi over 2. 2 pi over 3 is up here. That angle is 2 pi over 3. That's not within the range of sine inverse. So that won't be the answer. It can't be the answer. Sine inverse can't pop anything out bigger than pi over 2. So that's impossible. So let's just see what happens. This becomes sine inverse of, and just solve for 2 pi over 3. Sine of 2 pi over 3, that's equal to the square root of 3 over 2. Positive. Positive. Remember, sine is positive in the first and the second quadrant. So it's a positive root 3 over 2. And then what's sine inverse of root 3 over 2? Oh, it's just pi over 3. The reference angle of sine of 2 pi over, or of 2 pi over 3. It was just the reference angle, the positive. Huh, it's weird. It's like sine's positive here and here. If you ever get an angle that's hanging out in the second quadrant, you can just map it on over to the first and just write down its reference angle as the answer. I'll talk more about that later. Let's look at these two. We look at our angle, negative 5 pi over 6. And we want to know, since we're talking about tangent, inverse, let's look where our angle is. We want to know that we can only have values between negative pi over 2 and positive pi over 2, not inclusive of the endpoints. And negative 5 pi over 6 would be traveling this direction to here. Negative 5 pi over 6. It's also its coterminal to 7 pi over 6 if you wanted to know that. Oops, I can't put an equal sign there. That is not equal. But they're coterminal angles. You could say that they go to the same place. That would just be going the positive direction. Well, that's clearly not within negative pi over 2 to pi over 2, so it can't be the answer. What's the reference angle here? What is that from pi? Isn't this just going to be pi over 6? Cool. Cool, cool, cool. Cool, cool, cool. 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 All right. Yeah, that's got to be what it is. And, all right. Let's solve. Tangent inverse of tangent negative 5 pi over 6. So we can solve tangent of negative 5 pi over 6. What's the reference? It's pi over 6, right? So tangent of pi over 6, that's 1 over root 3. Was that positive or negative? How do we find out? Oh yeah, isn't it tangent positive here, negative here, positive here, negative there, right? So since we're in the third quadrant, that has to be positive. So we got, oh, it's tangent inverse of 1 over root 3. What's tangent inverse of 1 over root 3? What's the reference angle of negative 5 pi over 6? Anytime you play this game with inverse tangent or sine inverse, the answer will always be, when we're playing it only with tangent inverse and sine inverse, it will always be either the positive or the negative of the reference angle. The answer will always be the positive or the negative of the reference angle. But that only works for the sine inverse and tangent inverse. Cosine's an asshole. Cosine doesn't play like the rest of them do. And you know who else is an asshole? I am. I layer your tests with the cosine inverse. I make the quizzes all about it because it's a pain in the ass and it's the tough one. And if you can understand cosine inverse, I know that I have a student moving on that knows what the hell they're doing with sine inverse and tangent inverse. Now we could solve this right off the bat. We can look at this and play a game. Cosine inverse is only defined. Oops, no, we include that. Oh, I made it between 0 and pi. And 5 pi over 4 lies down here. Yeah? What's the reference angle? What's our reference angle in there? That's going to be pi over 4. But this one does not behave the same way. I'm going to give you the example where it's not the reference angle. It's the third frickin' quadrant with cosine inverse of cosine. This is the tricky one. Right now it's not so tricky because you can just solve for it. But when I change that 5 pi over 4 to a 4 pi over 5, 6 pi over 5, something that'll put you in the third quadrant. I misspoke on the first one. You're going to be hosed. So let's just run it. Cosine inverse of. Now, cosine of 5 pi over 4, we'd be like, the reference angle is pi over 4. So we go cosine of pi over 4. That's root 2 over 2. Then you're like 5 pi over 4. That would be down here in the third quadrant. And we have cosines positive here and here. And it's negative here and here. So the third quadrant and the second quadrant, cosine is negative. That's negative there, huh? So that means that our output would be that negative root 2 over 2. So we have cosine inverse of negative root 2 over 2. But this is where it doesn't behave the same freaking way. You can only have answers in the first and the second quadrant. If your input is negative, you're in the second freaking quadrant. If your input is positive, you're in the first quadrant. Well, we could solve this. These are the tough ones that are going through your homework. These are the ones I would ask you on the test. We would say that the answer to this is actually 3 pi over 4. The answer to that one is actually 3 pi over 4. That's the angle in the second quadrant that has the same reference angle. This is the tricky one. If you catch it, cool. If not, you're going to see it again. All right. The next one I'm going to come back, I'll actually give you some maps that show you where shit ends up going, and I'll do some of the tricky ones. See you then.